Welcome to the family vineyard. This is our private wine tasting room. This is where the family and friends taste our wines. And I want to use this opportunity to tell you about the Vinduino handheld soil moisture sensor. This is a device that is been designed with agriculture in mind. And basically it was designed for myself in the first place in order to understand what was going on in my vineyard with respect to irrigation water and how I can save water for irrigation. So for this year I set a goal to save 25% water, and we just had harvest, and I can tell you that we met that goal with margin. So let's talk about the Vinduino handheld soil moisture reader. What is it? What can you do with it? How much does it cost? And how do you get it? So first of all, how do you get it? It's not for sale. This is a prototype, and it basically is available for people who want to build it. So online you can find all the schematics, the PCB, the printed circuit board that connects all the components together, the display module, and also the description of the enclosure that is being used here. So when we designed this, or when I designed this, I had vineyard use or agriculture use in mind, and that's why the enclosure that I chose has the option of a rubber boot, like you can take it off like this, and it's making this unit very rugged. So reliable in the field. It also has a bright color, so if you lose it in the field, you actually are able to find it really easy. Then the other thing is it's easy to operate. It has only one button, the button here. If you push it, the system switches on. It takes a measurement and shows it in the display. And when you're done, you just let go of the button, and there's no more power consumption. So a device like this, which runs on a 9-volt battery, can last for years and years, depending on how often you use it, of course. Then the operation is really simple. You connect the leads to a soil moisture sensor that is buried somewhere in the soil at different depths, and by measuring at different depths you can basically follow the transition of the water to the soil. So the idea is, in order to save water, you want to get the water in the depth where the active roots zone is of your crop. In our case it's grapevines, so they're relatively deep, but that means that we measure within the root zones. We have 2 sensors there, and I placed one at 5 feet deep, which is just below the root zone, to measure water that is basically seeping too deep or percolating too deep and gets out of reach of the roots. So by measuring the soil moisture at different depth, I can manage my irrigation system to keep the water where it needs to be in the active root zone of the grapes. And by doing that, this year I managed to save 25% water compared to last year's. I have this gypsum sensor attached, but it's totally dry, so if I push the button, it will give me about 1.3 megaohm, 1% soil moisture. I'm gonna dip the sensor in a glass of water. So now, when the sensor is totally wet, we measure 237 ohms or 100% moisture. So, in order to determine how much water is in the soil, I connect this meter to buried sensors, and by activating the meter, I can actually read how much water is in the soil. In this case, the moisture is 74%, enough for this vine. So there are other design targets that I had when I was designing the Vinduino handheld reader prototype. Besides being rugged and suitable for agricultural use, long battery life, I also looked at how the performance needed to be. So with resistive sensors, you just cannot put a DC voltage on the sensor and measure the resistance. That would cause gas effects and electrolysis effects, so that would give you a wrong reading. So that's why you cannot measure the sensor resistance of a gypsum sensor by using DC voltage. You need to have an alternating current, and you need to do it as short as possible. So using the Arduino microcontroller board, I was able to program that exactly right. So we changed the current, the direction of the current through the sensor, and we also compensate for another effect which is called concentration cell voltage. So in the case of moisture in a sensor, depending on the concentration being stronger at one electrode or the other, this sensor is actually acting like a battery. So it generates its own voltage, which basically offsets the accuracy of the readout. So with the firmware we compensate for that. Another big advantage is that the software is totally open source and available for download to anybody who wants to have access to it. It also means that it's well documented and you can change it if you want to. So in this case, the firmware is optimized and calibrated for gypsum sensors, but if you want to use this device for another type of sensor device, suppose you want to use a professional watermark resistive sensor, you can do so. If you want to use this device to measure salinity, you can do so as well. So there's a lot of potential use for this device. Once you have the hardware, it's easy to reprogram and customize it to your particular need. Another potential advantage for people who have a need for it is to connect this device to a PC. So the Arduino board that is inside this unit basically allows you to connect the PC to it, and you can send the measurement data to your PC. The default frequency of measurement is every 3 seconds, so unless you change the programming, it will send the measurement result every 3 seconds to your PC. So you can track moisture going up or down. In summary, this prototype allows you to measure soil moisture. By measuring soil moisture at different depth, you can more accurately manage your irrigation. And you can manage your irrigation in such a way that you keep the water where you want it, namely in the active root zone of your crop. So by doing that, I saved 25% irrigation water this year compared to last year. This device is easy to make if you have a little knowledge of electronics. It should be achievable to make this with the information that is available online. It's not expensive. You can build this for about $20 to $50 depending on how much and where you buy the components. And that's about it. So I thank you for your attention, and feel free to contact me for any further information.